Okay, so today we are graphing absolute value. Oh, there we go. Okay, so I'm actually going to I'm gonna write up some notes in the notebook, not much still, there's just not enough room on this paper. So it's up to you if you want to do the same, write some notes in your notebook and then do the examples on the sheet, because that's where the graph is. I mean, you do your notes however you want. So give me a second, I don't have any clean sheets left, I thought I could. Of course not. Alrighty. Oh, just kidding. These notebooks, by the way, have been on sale. I just keep seeing them. It was like down to like $15. That's a steal. All right, so graphing absolute values. I'm calling this what, 2-2?
Oh, just say, who went home yesterday?
Okay, so we're going to start with graphing absolute value equations, and then we'll talk about inequalities afterwards. They're actually super easy, but let's get the basics of the equations down first. So there's a general form for these. You might have seen this, the H and K business before. Have you ever seen this? Maybe when you did parabolas at some point? I don't know. So we're going to talk about these quite a bit. So H and K, if you pull those numbers out and you look at them as an ordered pair, that is your vertex. So what I mean when I'm saying vertex of an absolute value graph, we mentioned already that they're all going to be a V shape. So the vertex is just going to be the coordinate of that point right there. So that wherever that is H comma K, and that's your vertex. All right, that's great. Well, what's the deal with that A out in front? A actually tells you about the slope of the right-hand side, this right-hand branch. All of your absolute values are going to be symmetrical. They're always going to do this. So whatever the slope is of this one's the same thing, just the opposite. Okay, we'll talk about that in a moment. So hello, happy Friday.
Happy Friday, I have 3 for you.
Oh, let's see. I have a lot of people absent. So she is absent.
Okay.
But these two are here.
All right.
Thanks. Lizzie and Jimmy. You have some slippy slips here.
Wait, is that him?
I just missed it. Sorry.
Wait.
Okay. Yes. So A out in front, that is going to be the slope of the right-hand branch.
That is flat, I guess.
I'm sorry, Jimmy. All right. I didn't know if it was like a secret or anything. I'm like, I just read what it said on there. That's what I'm confused why people are. Yeah, I don't know. All right, so that's going to be that slope of the right-hand branch. So if A is positive, your V shape is always going to be up. It's going to look like a V. If A is negative, what do you think you have? Yeah, it's going to be upside down V shape, right? So that's the basic those are the basic pieces of this. So before we take a look at trying some of these on the paper here, let me just give you an equation and see if you can tell me where the vertex would be. Okay, and it gets a little weird sometimes. So let's say you had an equation like this. Let's say it was x minus 4 plus 1. So if you look at this general formula, I know the vertex is going to be at h comma k. What do you think h is? It's 4. It's not negative 4. It's positive 4. Because think about it. If I were to plug 4 in for h right there, wouldn't it look like x minus 4? Right? If you plug in a 4, that means that h is really a positive 4 right there. So the vertex of this thing would be at 4 comma, what's k? K really is 1. So it's a little weird because the h term, you're really looking at the opposite, whatever that sign is. So yeah, that I want it to be a positive 4, and that would be a positive 1. And then what's the slope of the right-hand branch on this thing? It's just a 1, right? There's no number out in front here. So just like we never write the 1, right? When I'm writing an equation and the slope is 1, I don't write it. I usually don't write y equals 1x plus 2, right? We just write x. So if there is no number in front, you just know that it's a 1. Anything else, it would have to be written there. So if I were going to graph this thing, I could just go put a dot at 4 comma 1, and then on the right-hand branch, I just follow that slope, and then on the left, I just mirror it over. So we'll do that in just a minute. Let's try another one before we do that. I'll just add a equals 1, just so we are aware. Yep, a is definitely a 1 there. Let's try another example. What if I gave you y equals absolute value of x plus 5, and I just left it like that? What do you suppose that vertex would be? Everybody write it down. Write down what you think it is, and then we'll see if we all match. All right, Sam, I saw your hand up. What do you think it is?
A negative 5.
Correct. -5 is 0. I don't have any number written over here for k, so that must be a 0. Ms. Savia, there was no number over here, and you said that that was a 1. Why would this be a 0? Because we're talking about multiplying here, right? So if I'm multiplying by 1, it doesn't change the value. That's why we don't write it. But if that were going to be a 1, I'd have to have a +1 over there. So if there's literally no number, it's just a 0 for k. No number here for a is just a 1. Weird, right? But anyway, so the slope of this one is also just 1. All right, one more. What if I gave you that? Sure.
Why would it be -5?
So remember what you need. If you were going to plug in, say you thought it was at +5. If you plug in a +5, wouldn't that be x minus 5? Right? So it's always going to be the opposite. So, but if you plug in a -5 right there, you'd have minus -5, and that's how it's going to turn into that plus. So yeah, the h is always the opposite of the sign that you actually see in the equation. Okay, all right, so this one, everybody write down what they think the vertex is for this one. Write it down. You can write the slope too if you want. All right, who's got the vertex of this thing? Go ahead, Jill.
Is it 0, -7?
You are right, 0, -7. And then my slope, of course, is just that -2/3. So that would be an upside down V shape, right? Cool. All right, so let's try and graph a couple of these. Does it get harder than this? A little bit. Sometimes they're not in this form, but there's a whole bunch on our page that are in that form. So let's just take a look at the very first one. We have y equals absolute value of x plus 1. So doing what we just did, let's figure out where the vertex is going to be. Who can tell me the vertex on this one? Go ahead, Matt. You got it. -1, 0. So I'm going to go to -1, 0 on my graph, put a big old dot. That is the corner of that V, right? That's where the vertex is. Now I'm just going to follow the slope on the right-hand side. So what's that? The slope is 1. So from here, I'm just going to go up 1 over 1, up 1 over 1, up 1 over 1. To do the other side, I just go kind of in reverse. I'm going to go up 1 to the left 1, up to the left, up to the left. So I just mirror it over on the other side. And there, my friends, is an absolute value graph. What's so nice about graphs is you can always check this. If you're scared that you did something wrong or you went the wrong way, just plug in a number, right? So look right here. When I plug in 0 for x, I should get out 1 for y. You can test that so quick. Plug in 0 for x. Oh yeah, I got out 1 for y. So they are very easy to check. Let's jump down to, I don't want to do any of the inequality ones just yet. You try number 4. Okay, who can tell me where the vertex is? Jimmy, go ahead.
0, -4.
Correct. 0, -4. So I'm going to start my whole graph right here at 0, -4. And then what's my slope? The right-hand branch anyway. -1. So from this point to do the right-hand side, I'm going to follow the slope of -1. Down 1 over 1, down 1 over 1. So then to do the other side, I'm just mirroring it over, right? So this one's just going to go this way. So I have this upside down V shape that I was expecting because I had a -a. Anytime that a is negative, we're going to flip upside down. So far, so good? All right, let me see if I want to try just maybe one more that's like weird before we get to the really weird ones. Oh, gosh, they're all not that bad until you get to the strange ones. Let's jump all the way to number 10 real quick. Go ahead and try 10 super fast. Just so we have one more with a different kind of slope, I guess. Oops, sorry. Okay, you did it. Where's the vertex on this thing? Go ahead, Nate. Sorry. 0,3. Perfect. So I'm going to start this whole thing at 0,3. And then my slope is, everybody, -3. So on the right-hand side, I'm going down 3 over 1, right? Down 3 over 1. So to do that right-hand side, or left-hand side, sorry, I'm just going to go mirror it over, down, and to the left. Down to the left. Awesome. So you notice how A not only tells you if the V is going to be right side up or upside down, but it also changes like how wide or narrow that V is. So if you have a larger slope, it's going to be a steeper V, right? So if the slope is like 10, it's going to be really narrow compared to something like a slope of a half, it's going to get you a wider V. Yep.
I just realized that, wait, are we getting progress reports today?
Not unless they deliver them in the next half hour.
What's the advisory
That's a great question, which we already answered earlier this block. I mean,
Is it right after this part?
yes. Yes, I know. We'll talk in a little bit. I'm recording, so I don't want the whole internet to know our business.
Oh, yeah.
Yeah. Was it you guys that we were talking? We got totally off track yesterday because we were talking about people listening on the internet. Yeah, okay. I get confused. Oh, yeah, because I only record here. I don't record in B block, so it would have been you. Anywho, you never know. You never know who could be listening. I don't know. I guess we'll find out. All right, let's talk about the inequalities now. So I'm basically going to do them the same way. The only difference is now I need to worry about the signs and I need to shade. So I'm actually going to add this just as a note to my notes right here. So I'll just add a star. When graphing an inequality and inequality, we're going to do a solid line for, again, if it has the bar underneath it. And then we're going to use a dotted line to create our V shape if we do not have the bar underneath it. And then we also need to shade. So we are going to shade above if y is greater than or equal to. Shade below if y is less than or equal to. So that's sort of our cheat sheet for where we're shading. Very similar to before, right? I'm just shading above my line. It's a V shape though, so I'm going to shade above on both sides or below both sides, depending on which way we're going. Okay, so let's jump back to something like number 2 on this sheet. So you'll see we have an inequality here. But I start the same way. I'm still going to find the vertex. I'm still going to figure out, graph everything. It's just a matter of, do I do it with a solid line or a dotted line? And then I have to shade. So where's the vertex on this thing? Okay. 4, 0. Perfect. Right? Because remember, I always want the opposite of what I see in there with the absolute values. Okay. And it's not, you're not taking the opposite because it's absolute value. That's not the case. It's because our general formula is an x minus h. So anyway, 4, 0 is our vertex. Put a big old dot. And our slope is just a 1, right? So I'm just going to get myself set up. I'd go up 1 over 1, up 1 over 1, up and to the left. But now, friends, I don't just storm in here and connect these with a solid line. I'm going to stop and ask myself, should it be solid or should it be dotted? You tell me. Nate? It's got to be dotted. I do not have the or equal to bar underneath. So I want to connect these with a dotted line. And now I need to shade a region of the graph. It says y is greater than. So do I want to shade above or below? Above. So here's what I do. I just put my pencil on the vertex. And if I want to shade above, that means everything inside of this V shape. That's what gets shaded. How's that? Okay, try 3. So you try it. Set yourself up like normal. ask yourself, oh, this is an inequality. Dotted or solid, and which way am I shading? Okay, vertex is at 0.4 is correct. Slope is a -1, so this one's just going to be upside down. And tell me, am I connecting these dots with a solid or a dotted line? Dotted. I do not have that bar again, so dotted. I'm going to put my pencil on the vertex, and then I ask myself, okay, self, which way am I shading, above or below? Below. Y is less than, so that's going to be everything down here. You can always double check yourself by plugging in a point that you're shading over, because you're calling all of these answers. That's the whole point of the shading. Would an answer on the line be an answer? Not in this case, because that's why we use a dotted. So I'm saying everything up until this point, but you can't include this line. All right, let's jump. There's one more type that I want to do just to be sure before we get to the tricky ones. Yeah, okay, 9, it looks good. Okay, everybody try 9. All right, this vertex is at, Adam, you got it, 0,3. And ooh, this slope is 3, right? So I'm going to go from this point, I'm going up 3/1. Do the reverse on the other side. Dotted or solid? Dotted. And now, friends, where are you shading? Yeah, I put the pencil on the vertex. It says y is less than. When we say shade below, it doesn't, sometimes kids literally just do this. Below is anything below this line. It's basically everything outside of the V shape, right? Isn't all of this below? All of it. Does that make sense? So it's not just everything, because this keeps going. So this is all still below this shape. Right? If I keep going, all of this is still below. Okay. Are we feeling like these aren't so bad?
Yeah.
All right. So we're going to step it up a little bit of a notch, but it's not that bad. It's not. So if you take a look at something like number, I'm going to jump to like 14. Because now we've hit a little bit of a snag here, because this is not in the form that we've been talking about. Do you see that? Look at what we have. We can grab these, no problem. That look like some number outside, if there's going to be one. But then on the inside, I only have an X and then plus or minus some number. But if you look at 14, it's not just an X, it's a -2X. Well, that puts me in a pickle here. I don't know what to do with this, but there's good news. I can basically force this to look like this. I just have to do some fancy maneuvering. It's okay, we can do it. And you know what? I actually want to, can we start at 17's a little bit easier? So let me do an easy example of the tougher ones first. All right, so I'm looking at this. This is not the form that I'm used to. But does anybody have an idea what I could do to make this? Jimmy? Kind of. I can factor out a 2, right? I want this to just be an x. So watch how I can sort of rewrite this. I'm going to do y is less than or equal to absolute value. And now check this cool move out. Let's pull out a 2 from there. And then wouldn't I have x minus 1 if I factored out a 2? Right? I'm basically doing like reverse distribution property here. So if I pulled that back out, right? If I put this back through, doesn't that get me right back to 2x minus 2? So I haven't changed the value of this thing. I'm just rewriting it in a way that's going to help me match what I had before. Now, I'm not done yet because I still don't have x, right? I still have this 2 hanging out in here. But here's something that's so cool. When you are multiplying things inside absolute values, did you know that you could break them apart? Did you know? You can do this. So I can split this because I'm multiplying there, right? I can split it into the absolute value of 2 times the absolute value of x minus 1. That looks like one really long line. Let me just show that there's a break there. So I can split these 2 up. I know what the absolute value of 2 is. It's just 2. So check this out. Isn't that now a form that I can work with? Now it looks, yeah, I can do that all day. It looks just like the other ones now. So now go ahead and graph that. Where's my vertex going to be on this thing now?
Zero. Or wait, 1, 0.
1, 0. There we go. 1, 0. And now I have my slope is 2. So just do the reverse on the other side. Solid or dotted? Solid, because I do have that bar underneath. And then which way am I going to shade? Yeah, below, right? Y is less than. So I'm shading all of this. Everything below that V shade. If you're not sure, if you're shaky on this, you can go right back to the original and plug in a couple of points. So if this is the right graph, let's just say when I plug in +2, according to this, I should get out +2. Do you? Yeah. If I plug in 2, I get out 2. All right, cool. If I plug in 3, I should be getting out 4. Do I? Yeah. All right, cool. I did this right. Yes. Does that kind of make sense? It's weird, but it's nice to know. All right, even if it doesn't, if it's not in the form, I can make it be there. So let's shimmy over to 18 real quick. This one's a little bit different because I'm not I'm not factoring this out, but aren't I just doing -3 times x right there? Right? So can't I just, we just mentioned this, that if it's multiplication, I can split them apart. So what I can do with this thing, let me just rewrite it here. Oops, sorry. So since it's just multiplication in there, I can split this up into absolute value of -3 times absolute value of x. And now I know the absolute value of -3. It's just 3. So when I rewrite this thing, it becomes that. And that's something I can work with. Does that make sense? Try it. Go ahead and graph that one. Where's the vertex of this one? 0, -2, you got it. And we'll just follow that slope. Solid or dotted? And I'm gonna shade which way? Up. Y is greater than, so it's gonna be everything inside of this V shape. All right, so I did skip over 14, so let's go back because that one's kind of weird, but totally doable. It's just the numbers aren't so nice. So if we rewind back to 14. Whoa. All right, so I need this. I have to basically force factor out a -2. In number 17, it wasn't so bad because I could take a 2. It was a 2 and a 2. I can pull a 2 out easily. This one, I have a 3 here. 3 is not divisible by 2, but I have to make it be. So I'm going to force factor it back out. So what am I really doing? I'm really just dividing both of these terms by -2. So let's, let me rewrite it over here. -2x minus 3. Okay, so I need to force out a -2. So what would go in there? So basically I'm dividing each term by a -2. So if I divide this term by a -2, I'm just left with x, right? If I do -2 times x, don't I get right back to -2x? What would this chunk have to be? If I'm gonna go in here and divide this one by -2, what do you get? Oh, I heard someone say it, I think. +3/2, right? If you distribute that back in, you get a -2x, and now, right, if you do -2 times a +3/2, doesn't that come out to be a -3? So it's nice to just, before you keep going, just redistribute it back in to make sure that you pulled it out the right way. Okay, perfect. So now I've pulled out that coefficient that I needed to. So now let's split them apart. So I'm going to have y is less than negative absolute value of -2 times absolute value of x +3/2. I know the absolute value of -2, it's +2. That does not change the fact that there's still this negative hanging out in front. That's still there. But this chunk is going to turn into a +2. So when I put it all together, that negative is still in existence. This turns into a +2. And then I just have this absolute value of x +3/2. And that is in the form that I can graph. What's the vertex of that thing? Where is that? Say that again. You're so close. Yeah, it'd have to be a -3/2, comma 0. Because remember, whatever is in there, you really need to take the opposite of it. Not because it's an absolute value, but because it's x minus h, right? So that's going to be my vertex. -3/2 is just -1.5, right? So it's a little bit weird to graph this, but we can do it. So now just be careful when you're graphing the slope. So because my first point is not at a lattice point, just make sure you're going, oops, sorry, let me get it back in there. All right, so there's my starting point, and my slope is going to be a -2. So from that point, I go down 2 whole units to the right 1 whole unit. So that's still going to be floating in the middle, right? Down 2 whole units to the right 1 whole unit. So I'm always going to be sort of in the middle there. And then I just mirror it over on the other side. Down 2 to the left 1 now. Is that okay? So sometimes they're weird, but you know what? Weird is what makes the world go round. Solid or dotted? Dotted. And I'm going to shade which way? It says y is less than in the original. So I'm going down. So like that. What are our thoughts on this? Are these all right? Okay, so let's talk about what we should do for homework. So we've got about 8 minutes left. What if we did how about we just finish what's on the inside 2 pages? So just 7 to 18. And then you can take 1 picture of both pages. That's not so bad. So 7 to 18, but we've already done a bunch of those. Okay, so that'll give you a mix of some of the easier ones and then some that you still need to pull something out of. Yeah. Go so fast.
I go too.
Oh my gosh.
I
waited
waited.
Well, I can do, I don't know what the rules are anymore. I think I'm supposed to only do 1 at a time.
I feel like we're far enough to be able to.
Well, I know, but you'll have plenty of time. I mean, just go, yes, right. We have advisory. I'll give you plenty of time. So Jimmy's gonna go so fast. Okay, let's. Eight is greater than or equal. Okay, let me open this on Jupyter.